Hello everyone, my name is Erkin Ataytoka and I am an undergraduate student in Electrics and Electronics department. Today I am going to present you my term project for EE 2030. In this term project we were asked to build a create a experiment and design an experiment about light dependent resistors and distance measurement. And in this experiment we are going to examine the light dependency of an LDR, and we will try to design a distance sensor by using LDR. So in preliminary work I want you to do research about light dependent resistors. Here is a light dependent resistor, and let me explain it very quickly. Light dependent resistor is a type of resistor, and its resistance changes by the light intensity. And light intensity depends on the distance from the light source. So by using this information, we will try to make a distance sensor. And in step 2, we are going to analyze that. In step 1, I want you to make research about light dependency of LDR, and you will find that the distance and the resistor are exponentially related. So in step 2, you are going to try to linearize this exponential equation. You will work on the logarithmic scale. And in step 3, you are going to discuss how you can use this in our experiment. So let me start the experiment. In the first step, I am going to try to measure the resistance value of this LDR. So I will do it by connecting it to the I will do it by connecting it to the multimeter, digital multimeter, and I will use the digital multimeter in resistance measurement mode. And when I do it, I read the value in the lab environment as 1.6 kilo ohms. And now I will move to the part B. And in part B, I am going to use a light source, and I will use my phone's flashlight for it. So let me put it to the LDR and see how its resistance changes. So as you see, I was reading 1.6 and now I am reading 0.556, something like that. And now let me move closer to the LDR. Okay, I move closer to the LDR and I see that the resistance value drops to the 0.3. So let me move it far away. When I move it far away, I see that resistance value increases and it's like 0.92 kilo ohms, 92 kilo ohms. So let me move to the part C then. In part C, I am going to use the light intensity of my flashlight. As you see, this is in the full mode. So I will, I am going to decrease it, and we will see how this thing changes. Okay. Let me first use it to the maximum mode. In maximum mode, I am reading like 0.50 kilo ohms, and now I will decrease it one by one, and now I am reading 0.56. Now one more. Now I started to read 0.7 kilo ohms, and I will use the least value. And in this least value, I started to read 1 kilo ohm. So we see that when I decrease the light intensity, the resistance value dropped. So let me move on to the second part of my experiment. In this second part, I am asked to design this circuit. So let me do it very quick. probes of the multimeter. Okay, this is the circuit scheme. Let me do it a little bit. Okay, this is my circuit, and in this part I marked the distances, like here. Like I started from the 3 centimeters, 5, 7.5, 10, and it goes to 60 centimeters, like this, as you see. So I am going to use my flashlight again in the full mode, and now I'm going to start with the 3 centimeter here, and I will put like this, and I will read the resistance value and note it down. Then I will move to the 5 centimeter, and again I will read the value. Then I will move to 7.5, and I will go to the 60 centimeter like this. As you notice, the resistance value drops when I move away, and I will note all these values, but now I am not going to do it. Just before start this video, I did it, and I found the resistance values such as like this. I did it two different times, and this is the value. Okay, this is the newest values. So when I plot these values on MATLAB, here, this is my code. I obtain a graph like this, and if you observe that this graph looks like an exponential function, so I am going to utilize from logarithmic scale and take both sides of the logarithms of the both sides. I will use natural logarithm for it. You can use any base, and here this is the code for it, and for every data I measured, I plot the baseline for it, and I use polyval and polyfit functions for it. So let me run this code, and I got something like this. The blue dots are my data, and the red dot is the best linear line for that. And by using this red line's equation, I got something like this, okay? And I use the polyfit function, and the polyfit function's values, let me show it like this. It's like this. So I write this, okay, let me show it. It is ln r equals ln x equals a times ln r plus b, and the polyfit functions give me the a and b values. And this is for the red line that I showed you, and this is our equation. Okay. So now let me move to the third step, and now we are going to measure the distance from an arbitrary point. Okay. So I will take this point, okay, arbitrary point, and I set it here. And what did I see? I see 5.48, okay, and I mark this point. It's like here, okay. So I will be using my equation here for now. What did we? Sorry for that. What did I read? I forgot that. Okay, 0.551. Okay. So I read something like 30.7. So let me measure it with the ruler and see does that match? Are they consistent? And I read it with the ruler. It's around 29 centimeters, so which is very close actually. So let me use another point. I will use something here, okay? So let me read the value again. It is 0.413, 450, okay. So I measured it like 16 centimeters again. So let me measure. What does it correspond? It corresponds to 14 centimeters, so which is again close. And I wanted you to choose 5 arbitrary points. Try to choose them in different locations, so that you can comment on in which scale my distance sensor works properly. And okay, this is pretty much it. Thank you for listening to me.